Hello everyone, my name is Shiva. I'm from AMD. I'm excited to be here to present some of the issues or some of the challenges that we have been seeing using with the DPDK, and some of the issues that we are hearing from customers mostly. And together we just wanted to hear some of the thoughts from all of you and see like how we can have a community-driven solution to address some of those gaps. So with that, let me just share the agenda for today. So I just wanted to give a quick intro on DPDK packages and what are the current build configuration options DPDK currently supports, and both native builds as well as target-specific builds. And what are the performance challenges or gaps that we are seeing, basically, especially with packaged builds. And towards the end, I just wanted to propose a couple of suggestions and hear the thoughts so that we can just take an AR in terms of proposing those solutions and working towards it. So, okay, so why DPDK packages are, why are we really looking at packages? So these are actually supported by the distros, different distros. As DPDK is getting widely adopted by different companies from small scale to large scale. So, for people to get started, easy way for them to get going is just take the packages from the package manager, and so that they don't have to worry about the build infrastructure or dependencies around that. So, and just get going and use it perfectly fine. And the other thing is in terms of your cloud deployments or container deployments, basically packaged builds are a lot more easier to use and use. So there are different types of packages supported by different distros. These packages are classified basically for different operating system, different architectures for both 32-bit and 64-bit applications. And as I said, let's say if I want to get going with DPDK, if I want to build an application, I can just get the DPDK package from the package manager. Just specify the package config path and just link my application. Just go straight away. I can get going with that. But there are certain basically that does not give you the flexibility, which is what I just wanted to highlight here. So the current Meson build, Meson supports various configuration options with which you can actually overwrite the build configuration. So even you might we have a different architecture specific configuration, but all those things can be overwritten with the configurable options. That is really cool. The other thing with Meson is with the recent changes from Bruce, thanks for that. It automatically detects the dependencies. Basically, you really do not have to install all the dependencies unless it is really required. So the Meson is careful, will detect those dependencies accordingly. If some dependencies are not met, it just skips those components and proceed with the build process. And there are also options like if you wanted to trim your build to disable some of the drivers and libraries which you're no longer going to use, you can disable those drivers and libraries. That's also another thing. The other thing is this is one thing. You will have different platforms with the different configurations, and a static build configuration file is not going to be sufficient for all the platforms. So Meson exposes an option wherein you can just modify those configuration options with minus, or you can specify the option to automatically detect it, or you can specify option to just build for a specific platform, or you can build it for a generic platform, things like that. So what it means is, basically if I specify an option to build for native platform, the build configuration is tuned to that specific platform. That's absolutely fine. And your machine arguments are selected accordingly. There are other options like you can create the build for generic platforms, which means the build is created for a minimal CPU instruction set, which means it can run on any platform. There are other options like you can create a target specific build as well, like by specifying a configuration file with all those options. The DPDK distro packages are currently built with a generic option because the idea here is to to make sure that the build does not fail on any of the platform it runs. So there is a generic build which is expected to run on all platforms. So there is a basically there is a minimal baseline that is selected for every architecture for building these distro packages. So what we have been seeing, like with these packaged builds from different customers, right? So first thing is, like though Meson exposed an option to create native build or generic build, the build configuration, there is a certain set of static configuration parameters which is limiting how many cores that you can use. Or like, second thing is, like, I'm just, while creating a packaged build, so I might use a certain compiler version, it could be GCC or Clang version, but that compiler may not support all the specific microarchitectures, which means I can just specify it's a generic build with a minimal baseline architecture, which is absolutely fine. The second thing is, even if I'm creating a purpose build, like I'm creating a native build, if the compiler does not support the latest specific microarchitecture, it automatically falls back to the previous microarchitecture, and I will not get the best performance which I'm expecting. That is another problem. The third thing is, like since the generic builds are created with minimal CPU instructions, so there is a performance gap when we have observed from the customers, like when it comes to compared to the native builds. And there are certain cases like wherein the customers are creating a native build for a particular platform, but when it gets deployed on the field, so only the specific libraries are shipped, but it actually, there is a small change in the platform where it gets deployed. There are cases like there is a mismatch, but when we started to investigate those sort of issues, it is really difficult for us to figure out whether these libraries, because even if you look at the package config information, it says mmark is equal to native. That does not give us the information where it was actually built. Something maybe if the mmark could have been a lot more informative, that would have been helpful. That is one of the things. So we, as part of the investigation, we just took some of the references, try to evaluate where we are with respect to the distro performance versus the native performance. Here is some of the performance data. And there are certain cases where we see that the gaps are up to 20% for certain libraries. And this actually, in certain cases, there is even more than that. This actually brought, took us back to the basic approach that, so basically DPDK performance varies with the different attributes. We have to make sure that we use the right compiler version, you're specifying the right optimization flags to the compiler to create the optimal thing for the specific microarchitecture, and make sure that shared library is fine unless you really are concerned to use static library. And the other thing is, with that in mind, there are a couple of things that at least we propose to add. One is basically the static configuration thing, because for package builds, there is no way you can have a generic thing. So the best thing is to minimize those static configuration, especially in terms of the max number of L cores, things like that. There are other things is the current Meson implementation says if you specify mmark is equal to native, or the build is we think it makes sense to tailor the build for the specific host machine where it is running. Something like if the host machine is having 32 cores, it should just identify the 32 cores rather than picking it from the configuration file. Something something similar to max L cores is equal to detect. So that is one change that we propose. The second thing is the documentation changes as well. So basically this includes in terms of the compiler version requirements and other things need to be, I think, the quality, these things also need to be additionally included in the documentation thing. The other thing, in terms of packaging, as we cannot have basically one binary to tune to one platform and make it run on another platform. So the best thing for us is to have all the binaries packed into a single package. So that is, we think it's a better solution in terms of in terms of packaging, but again, like, wanted to hear from the community on what are the other approaches could be. Last, if the other alternative which we kind of thought about is basically to have different packages. But again, that becomes a problem in terms of maintenance, things like that in the long run. So and last, the versioning requirements have to be taken care of. Like, this is something that will work closely with the distros to ensure that the latest compiler needs were taken care of in the packaging. So with that, I conclude. Thank you.